a bunch of shortcuts, and hopefully they make sense to you. Okay? All right, here we go. Sorry, I should have prepped my work ahead of time. Hopefully you have this printout. All right, let's zoom into on a reminder of something that you might not have realized. But if I were to multiply 18 times 22, a calculator would be very useful. If I didn't have a calculator, there is a shortcut. And it might not seem like a shortcut because it actually looks like I'm doing something a lot more workish. That is, I'm not going to multiply 18 by 22, but rather 20 minus 2 and 20 plus 2. Now you might say, how is that a shortcut? Well, 400 I got by squaring 20, and then I'm going to subtract from it 2 squared. So 396 is what 18 times 22 is. Now that's a bit of a coinkydink problem because 18 and 22 are both equally distant from 20. So this isn't like an important thought about general mathematics, but it's an important thought about special instances of when we do certain multiplications. So today we're working with polynomials, and you're going to learn these 2 shortcuts. Idea number 1. That would be this one right here. If I multiply a plus b times a plus b, then I get a plus b squared. Now, whatever I write here is going to be the same as what we write here. So we only need to write it once. Let me turn this music down. All right, a plus b times a plus b. You are going to get the first things squared plus the second thing squared. Now I'm going to put that at the very end. All right? The middle part of this problem is twice a times b. All right? So notice how we have 3 different terms. The first term is the first thing squared, and then the last thing squared. And then the middle term is always 2ab. Now normally when we write this pattern out, we don't use parentheses because they're really not necessary. All right? When I do my second special case, this is slightly different but similar. Notice I have m plus n times m minus n. So these are slightly different. One's plus, one's minus. You get the first thing squared minus the second thing squared. And again, we don't need parentheses, so this is usually written as m squared minus n squared. Now you might be asking yourself, well, Mr. Larson, what about if they were both minuses? Well, if they were both minuses, that would just be another example of the top problem. The only difference is that the b is a negative number, a negative value, correct? So this would be a negative b, and this would be a negative b. But this last one, whether you square b or negative b, it's the same thing. You get a positive b squared. Yeah? So the only thing that's going to change when you have minuses is that this here will sometimes flip to a minus. All right? Okay. So some examples. Here we go. 3x plus 4. This is special case number 1 in your notes. So again, you're going to get 3 terms. A trinomial. You get the first piece squared. You get the last piece squared. But then the middle term is 2 times 3x times 4. So my final answer would be 9x squared plus 2 times 3 times 4. 24x plus 16. Ka-ching! Final answer. None of these pieces add up, so the trinomial stays as it is. All right, I'll do it now with a minus. Again, it's a little bit trickier. So we have a 5x squared. And we have a middle term of 2 times 5x. Don't forget that negative sign now on the y. And then the last term negative 2y squared. Negative 20xy and 4y squared. Okay. Hopefully that made sense. Example case number 1 now makes some sort of sense. Yes? Case number 2. What happens when it's a minus and a plus? This, again, little bit trickier. Here we go. So we have the first thing squared. We have the last thing squared. Don't forget you're subtracting these. So this is an x squared minus a 64. Done. Binomial. So again, because it's a minus, because it's a plus, and because I'm multiplying, then this is case 2. Right? So we have something squared minus something squared. So we have 3 squared and 8x squared. So you got 9. 3 times 3 minus 8 times 8 is 64x squared. I actually shouldn't write this as the answer because it's not written in standard form. I should put the 64x squared in front and the 9 at the end. That now is a better answer. Now, some people are wondering, why is this a binomial? Why do you only get 2 terms? What happened to the other one, kind of like case 1, where we have 3 terms? Well, what's going on, Mr. Larson? So let me use the area model here to explain. If I have x and negative 8, if I have x and positive 8. So notice again how we took each of these and I line them up outside my rectangle. And I multiply. I get the x squared. I get the negative 64. So what was here? Negative 8x. And here, 8x. These terms, in the special cases, will always cancel. One will be positive, one will be negative. So that's why you're only left with the first term and the last term. Good luck in your homework as you work through the 7-3 problems.